Welcome to Kal Academy. I have a short explanation here about the set difference, which I want you to understand it better. In set difference, we have two types of set difference. The first one we call it symbol difference, and the second one we call it symmetric difference. We call it symmetric difference. Then this one is symbol difference. So let's look at what is a symbol difference. The symbol difference is that the one that you get the difference between the two sets. E.g., let's just explain it clearly so that you take e.g. the element A. We know you minus, that is the difference B, or you take A and then B. This means that elements of A which are not in B. This means just elements of A which are not in B. Simply that I will say these are elements found in set A and are not in set B, and are not in set B, and are not in set B. So this is clear. In case you take B minus A or B, those are the symbols for symbol difference. We'll find that these are elements that are present in B. Elements are present in B and are not in set A. Elements are present in set B but are not in set A. Yeah. Think let's do an example here, and then again when you want to present it using the Venn diagram, which we shall cover it shortly, you'll find that if this is Venn diagram, they are the universal, then these are the two sets. Now this is set A and this set B. Let's work with the first one. This one is set A. When you take set A, it means that elements that are found in set A and are not in set B. Now you know this is the part that has only elements in set A. This part means intersection, meaning that now this part, the elements here are common, and then these others are elements for set B. And this is how it is presented using the Venn diagram. And then this you shade only this other part, showing that that is the difference between the two sets, symbol difference between the two sets. That's all. Then next, let's look at the same way you can again present when it is B minus A. Just be just the same. You'll find that when it's B minus A, those are the two sets, and then you'll find that that part, if this is B and this is A, you'll find that the elements that are in A are not in the intersection, are not in A. Sets that are only in B, not in the intersection point, and are not in A. So that's how you present it, B. Yeah, simple. Then let's look at now the symmetric difference. Let's now internalize what is symmetric difference. Symmetric difference. Yeah, in symmetric difference, this is a symbol for symmetric difference, and then we say that A, then that is a symmetric difference B, and then this one is that first of all you have to look at these two sets, that is set A and set B. Let's show you using the simple Venn diagrams for it to be clear. This is set A, then this is the set B. So now the symmetric difference is that element that is only in set A and not in intersection and not in B, like the first symbol difference. That's one. Then again, symmetric difference is now the elements that are only in B are not in intersection and are not in A. Then that's what. So this now you have shown, we call this one a symmetric difference. This means that the union of sets, the union of sets. We say the union of sets A minus B, the union of sets A minus B and B minus A. This now we form that is known as symmetric difference. The union of the set A minus B, and that's the union now, and the union again against the B minus A. That is we call it now the symmetry difference. Yeah, we are continuing with the same concept, that is the symmetry, and we want to do some more examples on the symmetry difference. That is symmetry difference, whereby we know that there are so many, there are around 3 or 2 symbols. The first symbol for symmetry is that one, then the second one is that one, and then the third one might even that one. Those are the symbols. So now we say that these two elements, we find that it is A union B minus A intersection B. These are, we're just confirming that these are just some formulas of calculating symmetric difference. Another one is A. B is the same as A minus B union B minus A. Yeah, that's just the formulas. So let's try to work with an example so that you can see how can it be. Then let A be a set of how many elements? Let's put like 1, 2, 3, 4, 5, 6. There are 6 elements. Then B has again 4, 5, 6, 7, 8, 9. These are 2 elements with those. These are 2 sets with those varying elements. Now, the first operation here is that we are saying that before we even apply the law, but what you should know is that calculating symmetry, simply this is a symmetry. So the simply is a symmetry difference. So first of all, let's start with this one, where we are saying A minus B, meaning that the elements that are in A are not in B. So that the first one, this is the first element, they are not in B. Then second, 2 is not in B. Then 3 is not in B. 4 is in B. 5 is in B. They are there. And then 6. So it means now the element here we find it is 1, 2, 3. Then again, let's look at the elements that are in B, not B, but not in A. What shall we get? B, not in A. 4 it is in A, 5 is in A, 7 is in A. So it means that there are 7, 8, 9. These are the elements that are in A minus B, 1, 2, 3. Then B minus 8, 7, 8, 9. Now, for us to get the symmetric difference, that's their union now. The union. So you'll find that now it is 1, 2, 3. Union operation. 7, 8, 9. And then you'll find that the answer is 1, 2, 3. 1, 2, 3. 1, 2, 3, 7, 8, 9. Let's show it in Venn diagram. Now, show it in Venn diagram so that now let's say this is A and this is B. So let me change the color so that I can differentiate elements of A. Let's start with the common elements. We have 4, 5, 6 common elements. Then let's look at the elements in A remaining. 1, 2, 3. In B remaining 7, 8, 9. Now the symmetric difference. This is now the symmetric difference. This is now the symmetric difference. There is a symmetric difference. Let's create here. And then let's show you the remaining difference. Yeah. Now you can now, as part of your assignment, you can now try to confirm this one that will still conform to it. And that's why we say that that is how you calculate set difference or symmetric difference of a set. Just two sets of A and B is a set of elements which are either in A or B but not in both. Yeah, then either A and B but are not in both. Thank you.